Hi everyone, myself are Gowthaman from 3rd BCA C section. In this final year, I made the project on image-based ransomware detection using deep learning with the feature exploration and Ensemble classification. Now let us dive into the PPT. So my topic of the final year project is image-based ransomware detection using deep learning with the feature exploration and Ensemble classification under the guidance of Mrs. Sharon Dominic ma'am. Let's move on to the next slide. So these are the outlines. Firstly, we are going to see about the abstract, introduction, aim, problem statement, proposed work, result and discussion, real world implementation, and finally conclusion. Let's move on to the abstraction. Ransomware detection is a critical cybersecurity challenge. We all know that what is meant by ransomware. Some of them, many of them not know that what is ransomware. It is nothing but ransomware is a malware attack, and if the malware is attacked into our system, the system cannot be accessed by the user. The total control is sent to the hacker and he encrypt all the data in our system. If you like to decrypt your laptop or PC, you need to pay the money to the hacker. So that's why it's called named as ransomware. It is one of the critical challenge in cybersecurity, and many of the ethical hackers are working beyond that to save the people. So in that way we take it's just a problem statement and we do with a deep learning, like we implementation some techniques here now discuss. Traditional signature and behavior based methods are inefficient against polymorphic malware. Now the malware is changing second by second and within changing its shapes and changing its types. So traditional methods are not even work to detect the latest malware. So if we want to detect the latest malware, we need to implement the new technology or we need to implement the new methods, prevent the PC from the malware attacks. So we proposed the image-based framework using deep learning with inefficient network B0 for ransomware detection. Efficient net B0 is nothing but is a pre-trained model with the ImageNet is a large data set. We use the pre-trained model here to compare both the Ensemble and the efficient 0. So move on to the next. Utilize data augmentations like cut mix and mix up. Dimensionality reductions like UMAP, PCA and Ensemble learning like XGBoost and LG Lite GBM. By using these all, we achieved the best accuracy of 98.3%, ROC of 0.9964, outperforming the conventional methods. It's truly very high score. It's truly very high accuracy in the CNN model. So the system provides a visual feature based insights into malware analysis. The approach is computationally efficient and suitable for real world deployment. Let's move on to the next slide. Introduction. As I already said to you, the ransomware is more dangerous and more financial. It creates more financial losses. In 2023, 64% of ransomware attacks are improved. So in that ransomware, how much of amount is ransomware collected is 2.73 million. So it's a very huge amount all around the world and also India. It's a huge amount. This is the main problematic statement here. Polymorphic ransomware evaluates traditional detection methods, altering its codes. As I already said to you, now the latest malware attacks are changing its structure, changing its code, changing its shapes to attack the system simultaneously, automatically. So if we want to detect that, if we want to prevent that, we need to implement more technologies or more need for advanced detection techniques that can identify evolve ransomware. Proposed solution. Here we propose image-based ransomware detection using deep learning to capture visual patterns in malware. The method leverages the small, strong pattern recognition capabilities of CNN, convolutional neural networks. The approach is designed to be the robust against adversarial manipulation, and here we move on to the flowchart. First, we do the image representations and data augmentations, effective net P0 pre-trained model, dimensionality reduction, clustering, Ensemble learning, performance evaluation, and then lastly in the program. This is our proposed flowchart. Move on to the aim. As I already said to you, our aim is to create the new technique, new system to prevent PC from the ransomware attacks. So here we also hit the high accuracy scores and we also compare with Ensemble classifications and effectiveness, and it is very useful and it is very easy way to implement in real world. It's our aim. Let's move on to the next slide. Problem statement. As I already said to you, traditional signature based are not working well in the latest polymorphic ransomware. So existing systems are finding lack. So we need to implement more techniques. We need to implement deep learning. Then we need to find the ransomware early before they attack us. So here is the proposed work. First, image representation. Convert executables into 224 into 224 grayscale images. 224 into 224 is the dimension. That's dimension is directly applied to the match to the effective net B0. That's already pre-trained model. So we convert the executable malware images into 224 grayscale images, and then we apply the data augmentations. Nothing but data augmentation is nothing but we use cut mix and mix up. Cut mix is nothing but the image is cut into two parts, and one part is here and another part will come attached here. Now it forms the new image, same as the mix up. So if the two images are included, so it helps to find the new ransomwares. The cut mix and mix ups are used to balance the data sets, and also it learns more to easily prevent the ransomware. Here we use dimensionality reductions like UMAP and PCA, principal component analysis, for to extract the important feature from the image, so that we can train the model in the best way. So we use the dimensionality reduction and Ensemble learning. We combine two learnings coordinately, so to get the model learn more effectively, more correctly, and also give the best results and best accuracy. So here we use XGBoost and Light GBM for final classifications. And exploratory analysis, as I already said you, UMAP and PCA. Already said to you, we compare that with the effective net B0, and then the effective net B0 is not good. After applying the Ensemble classifications, the results are so good, so we use this. So move on to the next slide. Results. Effective net B0 performance. Here I say to you, accuracy is 96% when only we use the images with the pre-trained model. Compare these two and we train the model, that's 96%. ROC is 99.42 and the precision is 0.99 for goodware and 0.94 for ransomware. Recall is nothing but 0.93 for goodware and 0.99 for ransomware. It's a result of effective net B0 performance. Coordinate with the Ensemble classifiers, as I already said, XGBoost and Light GBM. When we combine this, the accuracy score is slightly high. So how much percentage? The accuracy is 98.3% and the ROC is 0.9964%. The ROC is 0.9964. Precision is 0.99 for goodware and 0.97 for ransomware. Recall is 0.98 for goodware and 0.99 for ransomware. Confusion matrix and also precision recalls curve PR 0.9984, indicating the strong performance in the imbalanced data sets. To balance the data sets, we use the data augmentations to balance the data. The scores are too high. Let's move on to the discussion. The Ensemble classifier outperform the standalone effective net B0 model. The dimensionality reduction, UMAP and PCA and clustering like STBSCAN provided the valuable insights into malware feature space. The system is highly effective but would benefit from a more diverse dataset. We need to include more diverse dataset. Firstly, we use only few dataset, 5,000 images for ransomware and 1,948 for images for goodware. In future, we will definitely improve with more datasets to train the model. The integration of data augmentation and Ensemble learning significantly improved model robustness. The approach is scalable and can be adapted for the other types of model detections also. Let's move on to the real world implementation. Here I am going to run my model in the web page. So when we drag and drop the images, it automatically say whether it is goodware or ransomware. Let's dive into that. So here is the code for the model. Here I load the model here. So when I click run, the model is loading. Here we run it the localhost ransomware detection. Upload an image to detect whether it is ransomware or goodware. Here I click choose. So I move on to the two folders, goodware images and ransomware images, and these are all the goodware images. So I just click it, check whether it is says analysis is correct or not. Here it says the image is classified as goodware. As I already said to you, the model perfectly identify the goodware images. And this and then we tried into the ransomware. So here you are the ransomware images. So these are all the ransomware images. Just click on it and then click analysis. The image is classified. The result shows that the image is classified as ransomware. By seeing these results, you are definitely came to know that the model is work well. So coming back to the contents, conclusion, proposed an image-based ransomware detection system using deep learning and ensemble classification. As I already said to you, highest accuracy is 98.3% and ROC is 99.84. Surpassing the traditional methods, demonstrate the effectiveness of combining deep learning, data augmentation, and ensemble classifications. Future research will expand more data set real-time detections and also resource-constrained environments. The system provides a promising solution for next-generation cybersecurity systems. The approach can be extended to other domains, robust pattern recognitions. Here we conclude that traditional signature-based methods are not effectively work in this polymorphic ransomware. So we need to use more advanced techniques. So here we propose some techniques and we make the model using that techniques, and also the accuracy is so high. As you see, we already tested in the real world, so it's performed well. So in future we will just integrate with the existing firewalls to make the firewalls more stronger from the existing ones. So this is our project. So thank you for this wonderful opportunity that you giving us, and thank you for the guide, Mr. Sharon Dominic ma'am. Thank you ma'am. Thank you everyone.